Okay. We've got y equals mx plus b on the board. What in the world does that mean? It's the equation of a line, Noah. If I had a line and I said something like y equals, I don't know, 6x plus 2, what does the 6 and what does the 2 really mean? Yeah.
It's a coordinate.
6 and 2 is not a coordinate. Okay? It's not. That doesn't mean this line's going to go through 6, 2 on the coordinate plane. But you're thinking along the right line. 6 does mean something. 2 does mean something. Remember? No? All right, so the m is your slope. How steep your line is. Okay? Your b values, in this case 2, is your y-intercept. Where does it cross the y-axis? So if I had a line, coordinate grid like this, and my line was y equals 6x plus 2, I would look at this first and say, well, I know it crosses at 2 on the y-axis, and I know it's really steep. A slope of 6, so rise over run, so rise of 6 over just 1. Oops. So I go 1, 2, 3, 4, 5, 6 over just 1. 1, 2, 3, 4, 5, 6 over just 1. So you have this really steep line, a slope of 6, and it goes through 0, 2, y-intercept of 2. Remember that? We like to use this format for the equation of a line more than anything else because it's very quick and easy to graph. And remember, when we graph something, that means we've just found the infinite number of coordinates, all of the x's and y's that go together that fit in here perfectly. Okay? So this is y-intercept form, or sometimes it's called slope-intercept form, and the reason is because you're given the slope, you're given the y-intercept. Make sense? We're going to learn another form for an equation of the line. And this one is called something different. This one is called point slope form. And it's called point slope form because if you're given a point and you know the slope, you can come up with the equation of the line. This one looks like this. It's y minus a y that you know of from the coordinates, so we'll call it y sub 1. That's equal to the slope times x minus the x that you know of. Okay? So if you know, for example, if you got a line here, and you say, well, I've got a point out here that's specifically at 3, 2, and I know the slope of my line is 2. Okay? You could write the equation of that line. You would say, well, I know the x that I know of from a specific point is 3, so that goes here. And I know the y value is 2, so that goes here. And we said the slope was 2, so that goes here. This y stays the same, so y minus 2 equals stays the same, x stays the same. So this would be the equation of that line. Okay? So here we've got slope-intercept form, which we probably like the best. And then we've got point-slope form, because this tells me a point, and that tells me the slope. Okay, so we're going to kind of take a look at both of these together, because we can actually change it from this form to this form. And we're going to see how that works together with graphing. Okay? So on your paper, if you got the one with the grid, this one says graph a line that has a slope of 2, and it passes through the point 5, 6. We don't really even need slope-intercept form, and we don't need point slope form to do this. If we're simply just graphing it, look at the data. I know it goes through 5, 6, so go ahead and put a point at 5, 6. 1, 2, 3, 4, 5, up 6. I know my line passes through that point, right? Now, is my line like this? Is it like this? Is it like this? It has a slope of 2. Well, slope, or the m value, is your rise over your run, right? And if it's got a slope of 2, that's like a rise of 2 and a run of 1. So if I'm graphing it, I'm just going from that point and saying, well, from this point, I'm going up 2 over 1, up 2 over 1, up 2 over 1. Or, if I wanted to, I could say down 2, back 1 to follow that same pattern. And you just get a bunch of these points on here, and pretty soon you start seeing where your line should be. Okay, so there's my line that I know has a slope of 2, and I know it goes through 5, 6. That make sense? That one's not too bad. We've done stuff kind of like that before. Now, let's take this a step further though. Can you tell me what the equation of that line should be? Let's first start with the form that we like the most. Y equals mx plus b. We call this slope-intercept form. Do I know the slope of the line? What is it? 2. Okay, so I'm going to rewrite, instead of m, I'm going to put 2. And by the way, my y is going to be the same, my x is going to be the same. Why do I have to keep an x and a y? Why don't those change into like 3 or -4 or something like that? What does this line represent? I said it before. Your equation of line represents, you got it?
All the points in like a Z.
Yeah, every single coordinate. So this, whatever we write as the equation represents this point and this point and this point and this point and this point, which are all different x's and y's. They've got to be able to change, right? So I can talk about this x and y and also this x and y. So we always have those in there as variables because the line represents those points. Can we tell what the intercept is? If I went down over, it looks like I get to here, here, right there. 1, 2, 3. Looks to me like it's a -4. So plus a -4, or probably a better way to write it is -4. Okay, so that's my slope of this, or that's the equation of this line in slope-intercept form. Or if you want to call it y-intercept form, that's fine. But now I also started showing you that other form that we could write this in was point-slope form. So you say y minus a y that we know of, and the y that we know of was this point, right, at 5, 6, so I know that's my y for sure. That equals the slope times x minus an x that I know of. There's the x that I know of. So again, we just plug this stuff in. The y that I know of was 6. The x that I knew of was 5. The slope was 2. Everything else simply stays the same. Y minus 6 equals 2 times x minus 5. So 2 ways to write this slope, or to write this formula. And to show that to you, let me go back over to Desmos where we can graph it very quickly. Okay, so the first equation of that line was y equals 2x minus 4. Let's graph that. Y equals 2x minus 4. Okay. So there's our line. It looks pretty similar to what we had graphed by hand. Let me put this formula in there as well. Y minus 6 equals 2 times x minus 5. Y minus 6 equals 2 times x minus 5. Look at that, same line, isn't it? Okay. How can I have 2 different equations, but it's the same line? How is that even possible? Same thing. Just a different way of saying it, right? And also, when we go back here, we said that this equation, which is that line, is the same as this equation, which is that line. Watch what I can do with y minus 6 equals 2 times x minus 5. Y minus 6 equals 2 times x is minus 5, right? Yeah. If I tried to get this into this kind of format, this format, y equals mx plus b, just has y all by itself, right? So couldn't I just try to get y all by itself here? So I'd probably start by doing this. Y minus 6 equals, let's distribute this, 2x minus 10. And now I see that I've got a negative 6 attached, so let's add 6 to both sides. That'll leave me with just y on this side. Over here I have 2x minus 4. Y equals 2x minus 4 then is the same as this. Well, wait a second, y equals 2x minus 4. It's just reformatting that equation, right? So why do we have a couple different types? Well, because this shows us a specific slope and a y-intercept. This shows us a specific slope and a point. So depending on the information that we're given, sometimes it might be easier to start with this even if we want to get it in that form. But all three of them, this and the graph, all represent the same thing. An infinite number of inputs, x's, and outputs, y's. Okay? Let's try another one. Graph this line. I think you guys can do this one on your own. And I'll do up here and we can check. And it goes through negative 1, 1, so I'd start with that point. Draw your line that has a slope of 0, which should be really easy. That's sad. Is that your line? Okay. Could you write this as an equation that fits slope intercept form? I'd start with this. Where does it cross the y-axis? Okay.
At 0, 1.
Yeah, and we don't have to say 0 really, it's the y value there, so just 1. It crosses at 1. What's the slope of the line?
0.
0, so we got 0x plus 1. And if I simplify this, do I really even need to say 0x? No. So this equation of the line is just y equals 1. Sound good? Okay, let's take a look at another one. Here we're going to focus more on the equation. So going back to the point-slope form or slope-intercept form. Write the equation of a line that has a slope of 6 and passes through that point. Now, we've already done this where I could start by graphing this. 2, 4, 6, 7, 3. I know it's going to go through that point, and I could have a really steep slope, so I could figure it out, and I'm going to have something that kind of looks like that. If you wanted to do that first, if you're more comfortable with it, that's fine. But I don't even need this graph to show me this. The fact that I've got information, a slope of 6, and a point, tells me I can plug it into one of those two forms for the equation of a line. Do I have enough information to use this form, which is slope-intercept form? Do I know the slope? Yeah. Do I know the intercept? No. Okay, so here's an example of where, even though that's my favorite one to use, I'm probably going to have to start by using this form instead. Because this one, point slope form, says that if I know the slope, which I do, and I know a point on the line, which I do, now I can make use of this. So here's where we plug in what we know. We know that we've got a slope of 6, so I'm going to plug that in for m. And then we know that it passes through this point. 7 is my x value, and 9 is my y value. So I'm going to plug in 7 over here for my x value, and 9 for my y value. Everything else stays the same. It's y minus that 9. It's x minus that 7. This is in parentheses. Put your equal sign in there. That's the equation of this line. Make sense? If I want to go back and now change that so it's in slope-intercept form, I could. Right? So there's nothing wrong with this. If I graphed this on decimals right now, it would look something kind of like that. But if I wanted to distribute and say, well, that's 6x minus 42, y minus 9 on this side, and then add 9 to both sides. Y equals 6x minus 33. Right? Now it's in slope-intercept form. These two things are the same. Which one do you want to use? Well, if you don't care, then just do that one. We didn't need to do the extra work, right? If you need to have it in this form for some reason, you can change it. We good with that? All right, so I got one more for you here. It's almost identical to this one that we just did. Write the equation of a line. You've got your grid if you want to graph it first. But here are the things that you know. You know 2 points. Okay, so think this through. If we're going to try to come up with an equation that fits y equals mx plus b, I need to know the slope and I need to know the y-intercept. Do I have either one of those things? Based on the given information? No. Could I find out one of those things or both of those things? What could I find out?
The slope.
I could figure out the slope. Could I figure out the y-intercept? Not really, unless I graphed it all out first and it was I could tell for sure it passed through a point. So take a look at the other one. Y minus a y that I know times m times x minus an x that I know. Do I know the slope? No, but you said I could figure it out, right? Based on those 2 points. Do I have a point? Sure, I got 2 to pick from. I could use this as my y and this as my x, or I could use this as my y and this as my x. You guys good to go on your own with that guidance? You are going to have to figure out the slope first and then plug it in. Go ahead and give it a shot. I'm going to fill up my Super Bowl champion Green Bay Packers cup with water. You gotta become a Packer fan? There's still room. There's still room on our fan team for you.
Stop trying to suck us into your cult.
There's just more reliance on the Packers than the Bengals.
I'm not saying the Bengals are good. I'm saying you don't want to
Are you a
get
Packer
sucked
fan?
into a Packer cult.
There's still room for you.
Welcome
Welcome to the season.
What?
Noah, Trevor, how we doing?
I got the slope.
What's the slope?
7 over 5. Unless
How'd you get that?
I did 4 minus negative 3. And then keep under that 7 minus 2.
4 minus a negative 3, so change in y over change in x. 7 minus 2. 7/5. Agreed. That's your slope. So now what? Yeah.
You plug in the numbers.
Yeah, take that 7/5, plug it in for m. Now what are you going to plug in for your y and your x? You got options, right?
For y, you do negative 3, and for x, you do 2.
Y minus a negative 3, and for x minus 2. Sure, so y minus negative 3 is really like plus 3. That's your equation. You could have chosen a different point. You could have used 4 and 7, right? We could have said y minus 4. And there's our 7/5. And x minus 7. That would have worked too. Why do you think, again, just think through, how is it possible that we could have used either one of those? Aren't those 2 different equations of a line? Nope, not really. If I start distributing this and like solving for just y, it's going to end up being the same thing. Okay? So here's what I'd like you to do. On the back side of your paper, without looking at the board, I want you to write down what is the equation of a line in point-slope form. That's the one we like most often. And what's the equation of a line in, oh no, I'm sorry, I got that wrong. Point slope form is the new one that we just used. What's the equation of a line using slope intercept form? Got him? Y equals mx plus b, and y minus y sub 1 equals m times x minus x sub 1. Good? So it doesn't matter which form we use, they both make the same line or the same graph. Sweet. That's all we've got for today.